Assalamualaikum and hi to everyone. Thanks for watching this video. So in this video, we'll continue on another topic. Is about the operating system operations. So in the previous video, we already discussed about the role of the operating system. So in this subtopic, we'll look on the operation. Okay, computer startup. So bootstrap program is loaded the power up or reboot. Okay, bootstrap here is not the framework for the web front end technology, but is about the power up or reboot your computer system. So typically it's stored in the read-only memory or the erasable program read-only memory. So it's also known as the firmware. So these bootstrap program are stored at your firmware. So initialize all aspects of the system and load operating system kernel and start the execution. So bootstrap program is referred to the simple code to initialize the system and load the kernel. And then kernel loads and then start a system daemon. Okay, and the OS also known as the kernel interrupt driven for the hardware and the software. And the hardware interrupt by one of the devices about the software interrupt is referred to the exception or the trap. Okay, just like when you do the programming part and then you put a try and error for the exception for certain part. So that software interrupt known as the exception or trap. So the other term here, exception or trap, refer to the software interrupt. How if we talk about the hardware interrupt, it's referred to the devices itself. So software interrupt refer to the software error. Okay, let's say you have number and you try to divide that number by 0, so it will interrupt your software application. And requests for operating system services known as the system call. This one is under the system software interrupt. And the other process problem include infinite loop, process of modifying each other or the operating system. That's also referred to the software interrupt. Okay, this part is about the multi-programming. So we have bash system. The single user cannot only keep the CPU, the central process unit, and the input-output device busy. So multi-programming organize the job and code the data. So the CPU always has one to execute one by one. A subset of total jobs in the system is kept in the memory. So this one is the memory layout of a multi-programming system. So it look like we have a queue here. Here we have operating system, process 1, process 2, process 3, and process 4. So this one is the memory in multi-programming system. Okay, one job selected. Okay, one job selected. Let's say we have 4. So one job selected and run via the job scheduling. Okay, job scheduling means which one should be processed earlier. Okay, so job scheduling will select that process. So when job has to wait for the input or output, for example, you need to input to wait for that part. So OS will switch to another job. So it will process another job. For multitasking or timesharing, a logical extension of batch system. So the CPU switch job so frequently that the user can interact with each job while it is running. It's creating the interactive computing process. So response time should be less than 1 second, and each user has at least one program executing in the memory. It's the process of execute the program. If several jobs ready to run at the same time, CPU will do the scheduling part. And if processes don't fit in the memory, swapping move them in and out to run. Okay, we use the swapping. The term is swapping. And creating another part is visual memory. So this visual memory allows the execution process not completely in the real memory. Okay, the next topic we discuss about the dual mode operation. So these dual mode operations allow the OS to protect itself and other system in the computer system or in the system components. The dual mode or multi-mode operations is used in order to distinguish between the execution of operating system and the user defined code, between the operating system, the execution of operating system code and the user defined code. So there are two code, user code and kernel mode. So kernel mode is more on is about the execution process of the OS, and user mode is refer to the user part. Okay, and then we have another term, mode bin. So this one is provided by the hardware, and mode bit is based on number 0 and 1, 1010. Okay, it provide the ability to distinguish when the system is running the user code or the kernel code. So you can look at this diagram, the transition from user to the kernel mode. So user mode is identified by 1 and the kernel mode by identified by 0. So it means that if the mode bits is equal to 0, so that is the kernel mode. When the mode bit is equal to 1, so that is the user mode. So here, when a user is running, mode bit is user, refer to the user. When kernel code is executing, so mode bit is kernel. So easy to distinguish between the user code and the kernel code. So how we want to guarantee that user does not explicitly set the mode bit to the kernel. So system call change mode to kernel and return from call reset it to user. So this process on how to guarantee that there is no set mode to be to the kernel part. And some instruction designated as privileged and only executable in the kernel mode. Actually, in the operating system, we have multiple mode or dual mode. Instead of user mode and kernel mode, you may heard about the supervisor mode, the system mode, the privilege mode, and the mode bit. That are the term in this dual mode or multi mode operation in the OS. Okay. The next part we discuss about the timer. So the timer in the OS is used to control. Okay, we use timer to control the OS, to control it over the CPU. So to what we can say, let's say if a user program stuck in the infinite loop, okay, some program is stuck in the infinite loop or fail during the process of running. Okay, so we can use a timer in order to control or prevent that kind of failure or infinite loop. So the timer is set to interrupt the computer after some of period or duration. So we can use this timer in order to set to interrupt based on the current situation. Okay, a timer can be set to interrupt the computer after a specified period or certain duration. So the period, maybe we can fix the period or we can make it a variable timer. So let's say we have running a program. So in certain period that we already set, okay, in certain period, it not return to the operating system, so we can interrupt the process and close the process. Okay, in the simple words, okay, let's say you run the program is still execute under the user part, under the user mode, but in certain period, it doesn't goes back to the operating system mode. So we use the timer in order to interrupt and close the program. Okay, that is in the simple word. So keep a counter and decrement it by the physical clock. So the use of this timer is to counter. So it will decrement the number until it reach 0. Okay, when the counter 0, generate an interrupt. It will count. When the program start, for example, when the program start, so the timer here will count. So it will count from, let's say we put 10 to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then it goes to interrupt if still at that point. Okay, so set up before scheduling process. Okay, this timer is set up before the scheduling process to regain control or terminate the program that exceed the allotted time. So allotted time is time that being allocated. So this is the function of timer on the process, on the operation of the operating system. So that's all for this subtopic on the operating system operation. So next part we'll go for the management part. Okay, for the process or resource management. So that's all. Thank you and assalamualaikum.